The second example is called NetProbe. They help people find bad guys on eBay. So its work published back in 2007 in the World Wide Web Conference. So the problem is very simple. We just want to catch the bad guy. Bad guys who take your money but never deliver items to you. So it's a big problem. This is a very, very common problem. In 2010, it's a number 3 online crime. But the problem is actually very hard because if you view the online auction, say a network of users, that the user here is either a buyer or seller, and a transaction will be represented in an edge, then you have this large graph of users and transactions. And how do we find out which of them are good, which of them are bad? So we did a lot of digging. Well, I did a lot of digging personally. I found that the bad guys are actually very smart in how they operate. So on eBay, if you've used eBay before, you know each user on eBay would have a reputation score that's based on the feedback that you collected. So usually, if the transaction is good, then your buyer or seller would say, well, you're a good person. Well, transaction is good, I give you a thumbs up, so +1. So you just add all these numbers together, then you have a reputation score. So I found that the fraudsters have some very elaborate scheme in how they can boost the reputation. They would create 2 types of identities on eBay. So that means one real physical person would create multiple identities on eBay. And they would create those in 2 groups. One I call the fraudster identities, who eventually trade with the victim identity. And then the other group is what I call accomplice identities, who act pretty much like honest people, but occasionally they would trade with the fraudster. So why would they want to do that? The reason they do that is because they want some really heavyweight transaction. Meaning that for some really expensive items like an LCD TV, a laptop, and so on. So for those, the accomplice would trade the fraudster. But there's actually no real money changing hands here. But on the surface, it looks really good because as an average user, you want to buy from this fraudster, then you will look at the feedback history and you say, whoa, this person really paid on time and really paid that large amount of money. Right? So these fraudster identities look really good. So what I was describing here is actually what we call a near bipartite core pattern. So it's bipartite because we have 2 types of nodes, and there's no edges between the identities in the same group, but only between them. And it's a core because it's a graph in the large graph, and it's a near bipartite core because there are actually some missing edges between the fraudster and the accomplice. So having identified this as the near bipartite core, now the big question is how are we to detect it? So it's actually a very challenging problem. Back in 2007, there's practically no way to do that. So we tried a lot of methods, and we found that we could actually use the lead propagation to it. But in this case, we are not using just homophily, but we're also using heterophily. So what I mean by that? So if you look at this chart, we have 3 types of identities. If we are using the heterophily idea, then the 3x3 matrix that describes what's happening here would be like this. It means that things in the same group, they're actually not likely to link to each other. So here, fraudsters are not likely to link to a fraudster because they don't want the transaction to link those identities together, and if one gets discovered, the other would probably get discovered very easily. But the fraudster would very likely be trading with accomplices, so high likelihood. So darker here means more likely. And fraudster also is not likely to trade with honest people until the very end when they want to defraud them. So similarly, for accomplice, they would trade with fraudster. They wouldn't trade among themselves, and they would trade with honest people because they would like to act like honest people. So similarly, for honest people, they wouldn't trade with fraudster until the very end when they defrauded, but they would trade with accomplice because they don't know they have accomplice or bad guys, and they would trade with other honest people. So this matrix is actually exactly describing the near bipartite core that we want to detect. And so we put it into the group. So the propagation is one of the inputs, and we're able to flag real near bipartite cores in the data. So for this experiment, we crawled eBay for over 800,000 transactions among 66,000 users. So the red node here are confirmed fraudster. And also there are many other accomplices that the user has not reported. So this work received a lot of attention, including eBay, so they invited me to go give a talk on campus, on their campus. And also up here, I mean, you hear outlet, like Wall Street Journal, USA Today, CNN, and so on. And very interestingly, it also attracted the attention of Symantec. Actually, that's how the Polo project got started, because they saw this press releases and they thought, well, maybe it would also work well for our case, and it did work well. And also very interestingly attracted the attention of Belgian police, who emailed me for the source code, and they signed Belgian police in their email, which, well, yeah, I think they were the bad guys, so we ignored them. And for NetProbe, we also developed a user interface for it. So the user interface can help let people look at the detector result and mouse over the identity, the fraudster, the accomplice, and learn more about it. But this is purely for presenting information for a user. And sometimes NetProbe makes mistakes. And through this interface, there's no way to correct those mistakes. So that brought us to the second part of the talk. So when the algorithms make mistakes, how can we incorporate user feedback to help improve the graph mining process? And for that, I'll give you an example system called a Polo, which basically bridges the gap of data mining and HCM. So it combines machine learning and visualization to help people explore large graph data.